All right, here we go with section 11.2, which deals with another topic in probability, which is called experimental probability. But before we talk about experimental probability, we have to have an idea what the word sample space means. Very simply, sample space is a list of all possible outcomes in a given probability situation. For example, let's talk about flipping two coins. Very simple example. But if I wanted to list the sample space, I would need to list all the possible outcomes when I flip two coins. Well, that's pretty easy. The first coin could be tails and the second coin could be tails. That's one possible outcome. Well, what else could happen? Well, the first coin could be tails and the second coin could be heads. Or the first coin could be heads and the second coin could be heads. Or I could get heads on the first coin and tails on the second coins. Those four are the only possible outcomes, which is the list of my sample space. The sample space lists them. There are only four outcomes. What does the fundamental counting principle say about that? Well, you learned on the prior video that the fundamental counting principle says to multiply all possible outcomes. Well, on the first coin, I could get two outcomes. When I flip the second coin, I could also get two outcomes. And if I times those together, there should be four total outcomes in my sample space. Second example is going to be rolling two die. I want you to turn to the top of page 803. Yes, please do so. I want you to open the top of page 803 and look at it. On the top of page 803 is the sample space for rolling two die. Most people assume there are 12 outcomes when you roll two die, but that's not what the fundamental counting principle says, because when you roll the first die, you get 6 possible numbers. And when you roll the second die, you also could get 6 possible numbers. And when you times those together, you get 36. There are 36 total outcomes in the sample space when you roll two die. Make sure you memorize that. Now, let's talk about experimental versus theoretical probability. Using the idea of sample space will help us. Now, experimental probability. First of all, the definition. The definition is the probability that an event happened. The key word is happened with ED at the end. It did happen. Based on gathering data. You're going to hear me use this phrase a lot. Experimental probability is what did happen. It did happen. That's the key word. Something that already occurred. All right, now the formula. We all know probability is expressed usually in fraction form. Well, the formula for figuring out experimental probability is the number of times the event did occur, whatever that event is, number of times that it did occur, divided by the total number of trials. How many times you actually did the experiment. That's the formula for experimental probability. Theoretical probability. The definition. The probability that that should be the word an event will happen. The key word is will. It's in the future. You're going to hear me use the phrase theoretical probability is what should happen. Theoretical probability is what you already know. Like what's the probability What's the probability of getting tails on a coin? That's a half. That's what should happen. Half the time you should get tails, half the time you should get heads. That theoretical probability is the probability that you already know. Well, what's its formula? The formula is the number of ways an event can occur divided by the total number of outcomes possible. Having trouble writing today. Total number of outcomes possible. That's the sample space. How many total outcomes are in the sample space? That's the bottom number. And that's what experimental versus theoretical probability is. Now, let's do an experiment. Our experiment today is to roll one die and then flip one coin. That's the event that we're talking about. This is the event. Now, the question, what is the probability of getting a 1 on the die and tails on the coin? A 1 on the die and a tails on the coin. Well, let's figure it out theoretically. First of all, we could list the sample space. In theory, what should happen? Well, if I list the sample space, I could get on the die, I could get a 1 and tails, I could get a 2 and a tails, I could get a 3 and a tails, a 4 and a tails, a 5 and a tails, and a 6 and a tails. That's some of the outcomes. But I could also get heads on the coin, so I could get 1 on the die and heads on the coin, 2 on the die, heads on the coin, etc. And if I list all of these, you will see that there are a total, in the sample space, there is a total of 12 outcomes. All right, so what is my theoretical probability? My theoretical probability, the probability that I get 1 on the die and that I get tails on the coin, is equal to this. The probability I get 1 on the die is 1/6 times tails. The probability of getting tails is 1/2. Well, that equals 1 out of 12, which is equal to, I believe, 0.083, about 8% chance. 1 out of 12. Well, if I look at my sample space, how many of the outcomes have a 1 and a T? Well, you notice right there is the only outcome that has a 1 and a T. That would be 1 out of 12. That is my theoretical probability. All right, well, let's do the experiment. I made a little chart over here on the right for the experimental probability. You can feel free to stop the video and make that chart. And we're going to do 10 trials today. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to do 10 trials. So here we go. Trial number 1. Trial number 1, I got a 2 on the die and heads on the coin. Trial number 2, I got 1 on the die and heads on the coin. All right, trial number 3, I got 1 and tails. That's my desired event. That's what I want. Trial number 4, I got 2 on the die, tails on the coin. Trial number 5, I got 6 on the die, heads on the coin. Trial number 6, hey, all right, I did it again. 1 and T. Trial number 7. Yes, I did it again. Trial number 1 I got 1 on the die, tails on the coin. Trial number 8. I got 5 on the die and heads on the coin. Trial number 9. I got 4 on the die and tails on the coin. And the last trial, I got 3 and tails. Well, what is our experimental probability? Well, first of all, we did 10 trials. That is the bottom number. How many times did we get the desired event? Well, 1, 2, 3. So our experimental probability, what did happen was 3 out of 10, which is equal to 0.3 as a decimal, 30%. And that is the difference between the two probabilities. Now let's answer some final questions. Number 1, how close to the theoretical probability was the experimental probability? Well, if you remember, the theoretical probability was 0.083 and the experimental probability was 0.3. So my answer would be they were not close. The experimental probability was 22% off of the theoretical probability. There's a difference here of about 22%. Question number 2. What would make it closer? And here is the most important thing I want you to get from this video. The more trials you do, the closer the experimental probability gets to the theoretical probability. The whole key in life, people, is the more trials you do, the closer these two probabilities should get. And that's it. Now it's your turn. I'm going to pass out to you in class some simple experiments, and I want you to conduct them and find out how close your two probabilities are.